So today we're going to be learning about quadratic regression. So today's goals, we're going to find equations of quadratic regression using our calculator, just like we did linear and exponential regression in the past. We're also going to determine whether the correlation coefficient is a good representation of our data. Remember that in the past has been r, or r squared, okay? And then we're going to use our regression equation to predict some data, okay? So let's refresh our memory on how to do regression in the calculator. All right, we got some simple steps. First step is you need to enter in the data, and you do this under the stat button, okay? Remember, the stat button is right here. If you want to edit and type in data, that's where you would go to first, okay? You type in the x's into the L1, y's into L2. So once you do that, then you press stat again and go over to calculate. Now, we've done linear regression before, but today we're going to be doing quad regression, so quadratic regression. And again, if you remember, we did exponential regression, which was down here. Okay, so we're going to be pressing 5 from now on, okay? And if we're doing a quadratic regression, they're going to give us an a, a b, and a c. Okay, so we're going to have to type in an a here and write x squared, write b, and then write an x, and then we'll have a c in our equation. And then for correlation coefficient, we're only going to be dealing with r squared now. So the closer to 1, the more accurate our data is. The closer to 0, the less accurate our data is, okay? All right, so let's look at an example problem. So I've got pumpkin tossing. A pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will send pumpkins the farthest. One catapult launches pumpkins from 25 feet above the ground at a speed of 125 feet per second. The table shows the horizontal distance in feet the pumpkin traveled when launched at different angles. So use a graphing calculator to find the best fitting quadratic model for the data. So enter the data in our calculator. So I'm going to press the stat button, and I'm going to edit, and I'm going to type 20, 30, 40, 50, 60, 70, okay? So a hint, this is a quadratic equation. See how I go at 372, it goes up, it goes up, it goes down, it goes down, it goes down. So that's kind of a hint that this could be a quadratic equation. So I'm going to type in 372, 462, 509, 501, 437, 323. Okay, so once you type in the data in the calculator, to get the equation for the curve of best fit, we're going to go stat, go over to calculate, and we're going to press 5. Okay, I think you have to scroll down on yours, but this is your equation, okay? So we're going to round everything to the nearest thousands, so that would be 3 decimal places, okay? So here's my a, so I'm going to write negative 0.621 and then write x squared. So start with y equals negative 0.261, and then I need my x squared after my a value. And then your b value is 22.591, and your b value has one variable with it. And then you have your c value of a 23.029. Okay, so this 5 will bump that 9 or that 8 up to a 9, okay? So here is our quadratic equation. Notice it's got x squared and x and just a number, okay? So notice here's my r squared. So my r squared is a 0.999, okay? So that is great data, okay? So yes, it's a good fit. It's because it's very close to 1. So it's a good representation of our data. Okay, so remember, if your r squared is very close to 1, that means that this equation can be used to predict future events and be pretty accurate, okay? All right, so all the hard work is done, so now we're going to answer some questions using our equation up here. So what would be the distance of the pumpkin after being catapulted from a 55-degree angle? Okay, so typically, again, we're going to be plugging in an x value, and just to make sure that, yes, the angle up here is our x value up here. So let's plug in 55. Now, the tricky part is you got to plug it in twice, okay? So I would have negative 0.261, plug in 55. Do not forget the square. That's the most common mistake. Plus 22.591 and then I need to plug in 55 again, plus 23.029. Okay, so when we type that in the calculator, remember you type it in just how it looks. So I'm going to actually skip that step, but if you guys want to try it, press pause, because I'm about to give you the answer. So you would get 146 feet, okay, once you type that in the calculator. So does that answer make sense? Why or why not? Let's check up here in the table. 55 feet would be somewhere in between here. So I'm looking for a y value that's between 501 and 437, which that number is in between my data up here, so that makes sense. Okay. All right. Last question, what does the vertex mean in the context of a problem? So remember, if you're launching pumpkins, this is going to be where the pumpkin hit. And my max is going to be somewhere up here, which is called my vertex. Okay? So what does the vertex mean in the context of the problem? That's going to be where the pumpkin reaches its maximum height. So the point where the pumpkin reaches its maximum height. Okay, so again, vertex in a context of a problem is probably going to be a minimum value or a maximum value. Okay, so if you're launching things, it's going to be the highest point, and then we're going to see an example where it's different in a second. Okay, all right, so that's one problem. You've got another problem on the other side. So we're going to be now talking about, we have a study comparing the speed in miles per hour and the average fuel economy. So how many miles you get per the gallon. Okay, so I want you to try this one on your own. Press pause and then try as many questions as you can, and then we will go over them. So first type in the data into the calculator, and then remember stat, edit, stat, calc. So press pause. In this example, what I did first was I typed in this table into my stat, edit, typed them into L1, L2. Once you type in your data, again, go to stat and go over to calc, and then go down to 5 for quadratic regression. When you do that, you get this for your equations. You have your A, your B, and your C. So again, you write y equals, you write your A first, rounded to 3 decimal places. Don't forget x squared, plus your B with the x term, and then lastly your C. Your r squared was 0.965. So yes, that's a very good fit for our data because it's close to 1. So the data is very accurate, if you wanted to say. All right, so once you do all of that work, now you can answer some questions about your equation. So to make a prediction on how much fuel you would use if, how much fuel you would use after 42 miles an hour and 19 miles an hour. Okay, so my units should have been in fuel. But what you're going to do is you're going to substitute those values in into your equation. The people make mistake right here when they forget to type in the squared. So make sure you typed in the squared after you inputted your first x value, but not with the second. Okay. So when you plug in 42 in your first equation, you get about 30.7 fuel economy. I rounded to 1 decimal place because I looked in this table and saw they all had 1 decimal place. Okay. Again, on the second one, I plugged in 19. And I got 24.8 for my fuel economy. Okay. All right. Lastly, what does a vertex mean in the context of the problem? So the vertex here is a max because it goes up to about 30 and then goes back down. So what that would mean, it's your max. So it's the speed that you should go to get the best fuel mileage. It's the way to maximize your profit of driving. Okay. This is 100% true because if you go on the highway and you drive 80 miles an hour, you're not going to get as much fuel mileage as if you were to drive maybe 65 miles an hour. So the faster you go, the less miles per gallon you're going to get on your car. Okay, just cool data. All right, so that is quadratic regression. Now let me know if you have any questions. I can definitely help you with the calculator steps or any of these questions. Okay, but thanks for watching.